Hi guys, I hope you are fine. Me too, I'm fine. So guys, welcome once again to my YouTube channel and thank you for your support. So today guys, we are looking at this problem, and this is the problem of numerical methods. And today we are going to look at Newton-Gregory backward difference. So the first thing, I will read the question and then we go and look at it and do it. So the question states, the table represents a cubic polynomial fx equals to that. Use finite difference table and Newton-Gregory backward difference interpolation formula and determine. So we are determining f 3.6 and f 4.2, and here is our answers. So the first thing guys, we come and draw the finite difference table. And this is how we draw it guys. We come and draw the table as shown. We have x and we have x, fx. So after you draw these guys, we come and begin in the first derivative, which is that f, that is delta f, is our first derivative. And then we have delta 2, which is our second derivative. And our that derivative, we have delta to power of 3f. And so guys, so what we come and do is that for our first derivative, we come and say minus 4 minus 7, we get 3. For the second derivative, not the second, this value, we come and say minus 1 minus 4, which is 3. For this value, we say 8 minus 1 is 9. And then we come and do that until we come to this point. The same things happened for the second derivative. 3 minus 3, 0. 9 minus 3, 6. And like that until we come to where the 18 is. Finally, we come 6 minus 0, 6. 12 minus 6, 6. 18 minus 12 is 6. Now we come to solving the problem. So we come, guys, and first of all, we look at what do we require. We require 3.6. 3.6 is between 3 and 4. So we make this one. We now want to look for p. And this p is the fraction between 4 and 3 of 3.6 minus 3 all over 1. That fraction, we are looking at the fraction all over. The fraction means it is the difference between the required value minus the initial value. We can say this is the initial value divided by now the interval. That one gives us the p. From there, guys, we come and use now our formula. And the formula for backward, it's as shown. We have fx here, then plus p, which is now our fraction, multiplied by the first derivative, then plus p into bracket p plus 1 all over 2 factorial. You multiply by the second derivative, and then for that derivative, it is p plus 1, p plus 2. You multiply all that and you divide by 3 factorial. So now guys, at the same time, we have come and drawn the initial value, because we are talking of 3.6. Before we get to 3.6, we have gotten to 3. So 3, we consider it as our initial value. So we draw a dotted line like that. And when we reach here, we can now draw the diagonal like that. So these are the values we shall be using for fx, for first derivative, second derivative, and third derivative. And this is what now, guys, I have replaced here. For the first derivative, we had 21. 21 can be seen here, because this one was 29. For the second derivative, we had 12. It is here. And for the third derivative, we had, that is supposed to be 6. So when we work out that one, guys, we shall now be able to get 29 here, 12.6, then we have 5.76, 2.496, and then finally we get 49.856. And this is now our solution. Then we go to F4.2. For F4.2, we come to our table yet again. We look at it. Where do we find 4.2? We find it is actually outside the table, but now it is nearer to 4. So if it is nearer to 4, then this is going to be our initial value. So when we are looking for P, you'll have 4.2 minus 4 all over the interval, which is 1. And it is the one that is given here now, guys. This is now our P. Using the same formula, guys, of which I have not repeated it again, we shall get the fx is 6, that is from the table. Fx is that. First derivative is 39, we multiply by 0.2. And the third derivative, we have this, we multiply this, the third derivative, we have 18, as it is shown here, 18. The second derivative, the third derivative will now be 6. And so this is how we do it, guys, until we get to that answer, which is 78.488. For this one, I did not write the formula, but when you are doing it, make sure you write the formula so that you can remember all this. So guys, that is how we go along, or we use the Newton-Gregory backward difference interpolation formula. And so guys, from there, we now come to this question again. This question, we have done it some time ago, where we were supposed to correct an error. For me, right now, I have already corrected the error, so we are not going to correct the error anymore, because I have done that. So what we are going to do is that we are going to now find F4.5. Of course, the answer is given there. So I have drawn the finite difference table with the error already corrected. And the question says f raised to 4, f, not raised, but f4.5. So f4.5, we look at it at this, at the x, this column of x. Where do we find 4.5? It is between 5 and 4. And so guys, we come and say 4.5 minus 4 all over 1. This is our fraction now. Our fraction of that point we want, minus 4 all over the interval. The interval is 1. So our fraction is supposed to be 0.5. 0.5. So this is equals to P. And now from our backward formula, that is Newton-Gregory backward formula, we have this. We have fx plus p, you multiply by the first derivative, then p to bracket p plus 1 all over 2 factorial, you multiply with the second derivative, and then you go to now p, then p plus 1, p plus 2 all over 3 factorial, you multiply by that derivative. The first derivative, we draw a line here, guys, where we find our 4.5. And then from there, we can draw the diagonal like that. So fx is going to be 77, which is here. Then for delta, that is for derivative 1, we have 44 here, and which is here. And for the second derivative, we have 20, which is found here. And then this value is also there. And for the derivative, third derivative, we have 6. This is our 6 is for our third derivative. And after that, guys, we just come and fix our figures here. So once you have fixed our figures here, we can add at the same time we are also multiplying. And this is now what we get. Finally, we shall get 108.3.75 as our solution, guys, even as we had written here. So these notes are suitable for those who are doing division. And so, guys, just bear with me that I'm not doing the question right now. I have already done it, and this is how I have done it. So this is Newton-Gregory backward difference interpolation method. So guys, thank you for listening to me. See you next time. Bye bye.